Okay, good afternoon everyone. I am your host for today, Dr. Ajunta Mukherjee, Assistant Professor, Department of Chemistry, Maulana Azad College. Respected Principal, Maulana Azad College. Respected Vice Principal, Asutosh College. Respected Chairman, UG Board of Studies, University of Calcutta. Respected Head of the Departments of Chemistry, Asutosh College and Maulana Azad College. Respected IQAC coordinators of Asutosh College and Maulana Azad College. Distinguished speakers, all departmental colleagues, participants from across the country, and dear students. I welcome you all to the 4-day national webinar on discipline-specific elective topics of UG Chemistry Honours CBCS syllabus of the University of Calcutta. I thank you all for your wholehearted participation and hope that the lectures arranged during the 4 days will be enriching as well as beneficial for the teachers and students of UG Chemistry Honours. Without any further delay, I would like to request Professor Subhashish Dotto, Principal, Maulana Azad College, to inaugurate the event and deliver the welcome address. Sir, please.
Good afternoon, all. Honorable members of the Advisory Committee, Organizing Committee, Executive Committee, respected speakers, respected teachers, and my dear friends, and my beloved students. It is a befitting moment to extend for everyone present today to participate in the 4-day-long national webinar on discipline-specific topics of undergraduate chemistry honors CBCS syllabus under University of Calcutta. This seminar is organized jointly with IQAC and IQAC of Maulana Azad College and Asutosh College, Department of Chemistry, Asutosh College and Maulana Azad College. So I would like to convey my thanks to the Chairman, UG Board of Studies, University of Calcutta, Professor Choitali Mukhopadhyay, Vice Principal of Asutosh College, Coordinator IQAC of Asutosh College, Coordinator IQAC of Maulana Azad College, Head of the Department of Chemistry, Asutosh College, Head of the Department of Chemistry, Maulana Azad College. Special thanks to Dr. Kiya Ghosh and Ajunta Mukhopadhyay. As we all know that CBCS curricula provides an opportunity for students to choose courses from the prescribed courses comprising core, elective, and skill-based courses. Discipline-specific elective subjects have been introduced to make choice of education broad-based, flexible, and at par with global standard. It is, of course, which can be chosen from a pool of courses very specific or specialized or advanced or supportive to the understanding of the main subject of study. As per UGC guidelines, it provides an extended scope or exposure to some other discipline or subject and nurtures the students' proficiency. The essence of this system recognizes the fact that gone are those days of a system which is highly teacher-centric, focused on memorizing lessons, distancing students from using their cognitive abilities. This system provides an opening for the students to decide what they want to study from a pool of multiple choices. let us prepare ourselves to collaborate these new challenges in our academic journey, and this webinar is meant just for that. I wish the 4-day long webinar will be a huge success, answering all queries regarding the DSE curriculum of chemistry honors under CU. Thanks all. Thank you all.
Thank you very much, sir, for your lecture. Now, I would like to request the head of the Department of Chemistry, Dr. Ashish Kumar Mukherjee, Maulana Azad College, to say a few words. Dr. Ashish Kumar Mukherjee, sir. Please unmute yourself. Sir, please unmute yourself.
Hello.
Yes.
Thank you.
Yes, we can hear you.
Respected honorable guests and participants. Principal of Maulana Azad College, Vice Principal of Asutosh College, and my colleagues. This is the first time the Department of Chemistry, Maulana Azad College, Calcutta, is going to organize 4-day national webinar on discipline-specific elective topics of undergraduate chemistry honors under CBCS syllabus of University of Calcutta, jointly with the Department of Chemistry, Asutosh College, under the control of IQAC of both colleges and in collaboration with UG Board of Studies, University of Calcutta. Being the in charge of the Department of Chemistry of Maulana Azad College, I am proud of my young colleagues and also the faculties of the Department of Chemistry, Asutosh College, for their effort to organize such webinar, as it is now a new platform to discuss problems and also to exchange our views or ideas to each other. Several esteemed speakers are invited to exchange their views on their specific topics as given in the program schedule, and hope all participants will be enriched after the successful completion of this program. And also, they will be able to share their own views with each other, making this webinar a great success. Again, I express my heartiest thanks to all my distinguished guests and participants. Thank you.
Thank you very much, sir. Now, I would like to request the coordinator of IQAC of Maulana Azad College, Professor Shubhit Chandra Dasgupta, to deliver his address.
Am I audible?
Yes.
Yes,
sir.
Respected Principal, Maulana Azad College, Dr. Subhashis Datta, Vice Principal, Dr. Apurva Rai, Coordinator of IQAC Asutosh College, Dr. Tathagata Rai Chaudhuri, Dr. Choitali Mukhopadhyay, Chairman, Undergraduate Board of Studies, University of Calcutta, Dr. Ashish Mukherjee, Head of the Department of Maulana Azad College, Dr. K.A. Ghosh, Head of the Department of Chemistry, and all the faculty members of Chemistry Department of Asutosh College, Maulana Azad College, distinguished speaker, and the participating delegates. On behalf of IQAC Maulana Azad College, myself, Dr. S. Dasgupta, welcome all of you this 4-day national webinar lecture series on DSE topics of undergraduate chemistry honors based on the CBCS syllabus of the university, which was jointly organized by the Department of Chemistry, Maulana Azad College, Asutosh College, in collaboration with Undergraduate Board of Studies of Chemistry. This webinar will continue till 7th August, and during this 4-day, many interesting areas of chemistry will be discussed and worked out. I hope that this webinar will identify the problem of the DSE topics and enrich the knowledge of all the participants. I wish all the best of this webinar lecture series. Thanking you.
Thank you, sir, for your kind words. Now, I would like to request the respected chairman of UG Board of Studies, University of Calcutta, Professor Choitali Mukhopadhyay, to deliver the keynote address.
Good afternoon. So, is it okay, my voice?
Yes,
Can
yes.
you hear? Yeah.
Yes,
Okay.
yes, madam. You can do it.
Yeah. First of all, I'd like to thank the organizers for including me in this very timely and appropriate venture. There are two things in formulating a syllabus. Is that you formulate it, keeping in mind what kind of resources you have. The other part is implementation. And that part is more serious. It's as serious as formulation of the syllabus. And I am it's very reassuring to see that the chemistry fraternity has come up to address these problems of this introduction of new courses in this BSc honors syllabus of chemistry, that is discipline-specific courses, as my previous speakers have already mentioned. They are more specialized, advanced courses and more specific, I'd say. And they are geared for the students so that they have a better exposure, and their what should I say, the degree is more meaningful, and they have more scope in future. And it's then mandatory for the teachers to prepare themselves so that they can deliver the necessary ideas to the students, share their knowledge. And this webinar, the organizers have lined up a galaxy of speakers. I'm very impressed. And they are going to share their experiences, knowledge, skill, brainwaves, and whatnot. I'm sure the more experienced ones will have new insights, and the less experienced ones will have more assurances and more, and they will feel more encouraged to tackle these courses in the classroom. And I wish this webinar a very success. And since after every section there is a discussion part, and I expect all the participants will discuss heartily, so that all the various nonsense of the courses will come out, problems and advantages, whatever they feel, or whatever appropriate term it is. And it will be a very useful for everybody, whoever is participating and who will be benefited afterwards. Thank you once again.
Thank you so much, madam. Now, I would like to request the head of the Department of Chemistry, Asutosh College, Dr. K.R. Ghosh, to deliver her address. And after that, we will straight away go into the technical session, which will also be chaired by Dr. K.R. Ghosh. So, thank you very much, Dr. Ghosh.
Good day, everybody. I being one of the conveners of this 4-day long national webinar, I'm very grateful to the respected principal of Maulana Azad College, Vice Principal of Asutosh College, IQAC coordinators of 2 colleges to make it happen. Our respected chairman, Professor Choitali Mukhopadhyay, for her gracious presence and her valuable suggestions. I am grateful also to all participants, our respected teachers, as well as dear students, who are really hopeful about the outcome of this webinar. First thing, why we need this webinar? As DSE syllabus is very much new, so we need proper guidance from every nook and corner. And this is true for every student as well as every teacher. We have to digest it. Moreover, we need every student's learning in equal dimension. I think today's webinar and upcoming 3 days webinar will help us a lot. As time is very short for every semester, we know. So if possible, we need some kind of shortening if Chairman Madam Professor Chaitali Mukhopadhyay allows. So our speakers have taken huge responsibility to guide us. So I think we can have clear vision about this new DSC syllabus. Our first speaker today is Dr. Shubhra Ghosh Dostidar, Associate Professor in charge of Department of Bioinformatics, Bose Institute, Kolkata. His topic is DSC A1, Molecular Modeling and Drug Design. After his lecture, there will be interactive session, question answer session, which will be conducted by Dr. Priyatosh Datta and Dr. Niladri Shekhar Kaur. The meeting room audience are requested to post their questions in chat box so that the coordinators can go through them. Thank you, everybody.
Kia, if I just may add one thing.
Yes.
If I may, I cannot reduce the syllabus. Sorry, it's not in my hand.
Okay. Actually, চৈতালি দি যদি দুই একটা প্র্যাকটিক্যাল আমরা আনঅফিশিয়ালি একটু ডিসকাস করে নিই, মানে যদি মানে একটু ডিফিকাল্ট হয় সেটা তো এগ্রি করা যাবে না।
I cannot officially say that this can be done.
Okay. No problem. Okay. Thank you. So, Dr. Ghosh Dostidar, please.
Okay, am I audible?
Yes, very much.
Okay. Can you see the screen? Can you see the screen?
Yes.
Yes.
Oh, thank you. First of all, I feel privileged to talk here, and at the same time, I feel embarrassed because I'm talking in front of so many experts, and most of you are more expert than me in chemistry, and I hardly do chemistry these days. What I was told that I have to give a brief introduction on this particular module, that newly introduced module, molecular modeling and drug design. And it's not about covering all the details, but this is about how to introduce this course to the students. So what I have planned, that what I do when I teach, that what are the major things that I tell the students to raise their interest, and tell them, okay, see, because of this thing, you have to learn this subject. It's not that I force them, but I inspire them to learn. So this is how I do, and this is what, I mean, the same thing I'm trying to present here. First, the first question is, why do you really need a model in chemistry? Because since our childhood, we have learned that science is experiment, observation, and inference. And in chemistry, observation means color, order, etc., and other visible changes. Then why do you really need models? The answer, the first level of answer is simple. I mean, with this example, that when people had to solve this puzzle, that how 6 hydrogen could be fit into 6 carbon atoms, and all the valences will be satisfied, and how that would be possible. And then the question of having a structure came into play. Now, Okay, so this will give an idea that structure could be of different details. Like one could be satisfied with this kind of structure, one line formula. Okay, it has explained C6H6, but there could be some advanced level of modeling also when you will draw the details of the orbitals. So the choice of models depends on your purpose, depends on your objective, and the kind of calculation that you want to perform or the kind of facility that you have in your hand. So depending on that, you choose your model of interest. So, but this is very simple. For this, you really don't worry about having a subject like molecular modeling, but that would be clearer if I give this example of a more complex puzzle that Rosa Franklin took this picture of extra diffraction of a DNA fragment, but she could not solve it. Means she had this data in hand, but she could not tell that what is the possible structure of DNA that would lead to this kind of scattering. So one had to propose a model. That model will explain, okay, if this is the structure of DNA, then this is going to be this kind of image through extra scattering. So then this model came into play. There's Watson-Crick model that explained that, okay, if this is the structure of DNA, then the entire extra diffraction pattern is explained. So not only through model, but also through some other quantitative calculations.
So bro, sorry, you just click hide at the bottom line. It's constantly there. You just please hide. Click hide in the on the screen. The bottom line. Yeah, thank you.
Okay. So now the question is that, okay, so we have been using such ball and sticks model since our school level chemistry and also in high school, even in the colleges. Then why we really need this one, like handling these models in computers? Because molecular modeling and drug designing is a subject that is done in computer. It's not about only the ball and sticks model. The answer is that first, that when you do molecular modeling, when you handle bigger molecules, macromolecules, you can hardly proceed with this kind of balls and sticks models. You have to deal with many different conformations. You have to do quantitative estimations, and you want to see the real-time behavior of these molecules and others. And whatever you want to do, it is only possible if you transfer this model in computer and have a mathematical basis of presenting these models in computer and for further quantitative estimation. Okay, so so there are two ends. One is the simple text files. In this modeling, there are two parts. One is a simple text file that will contain the description of the atoms and the coordinates of the atoms. That is in the left side of my screen. So whatever manipulation that you do through your program, through other editing software, etc., it is done in this coordinate level. So then all these things are translated visually in using a software that you see, that you can see. So whatever changes whatever calculations that you perform on the coordinates, actually you see visually and you interpret. So these two things are correlated with each other, that the visual impression and also the programming and the calculations on the coordinates. So another level of complication is that, so far we have discussed only the static models, that one methane, ethane, or a drug molecule, static models. But in reality, these models and these molecules in real system are not static, because they all have kinetic energies and they have motions, and these motions are related to their properties. For example, water as a fluid, the diffusion coefficient of water, the dielectric constant, whatever we talk about water, you hardly can explain with one model of water that has one oxygen and two hydrogen that has partial charges, etc., certain bonding. No, hardly you can explain all these things. It requires a collection of water molecules, and they have certain orientations and interactions. And then even for ice, there's a specific type of orientation that leads to the ice formation. But in whatever situation they all have vibrations. Not in ice. I mean, in ice they have vibrations, but not rotation and translation. But in fluid water, of course. So all the atoms in reality, they are under this kind of thermal motions. So if we just generalize all the atoms, they are in thermal motions, it would be like this. But are they really moving freely? The answer is no, because they have constraint. The first level of constraint is this: they have bonds. So even one atom is trying to move in a direction, the bond may not allow to do it freely. So it has a constraint. But the bonded interactions are not the only constraint that they have. There are some more interactions which are not like bonds, but like this. They have network of non-bonded interactions. So now if you just try to think that, okay, possibly this is the main driving force which are holding all these water molecules together, and they are also controlling the motions of the atoms in addition to the control through the covalent bonds. So people have tried to mathematically explain these network of interactions, and there is an expression. Another thing that I have missed. When all these water molecules are moving under this constraint, each of them are having this kind of motion. Their bonds are vibrating, and the angle is also vibrating. So all these things are happening simultaneously, and we need a mathematical formula to capture all these details that is happening as a function of time. So this is the energy expression that will capture all these possible interactions which are there. It may seem to be complicated, but if I go term by term, you will realize this is nothing but the building block of the total energy of the system. For example, the first term reflects the bond vibration as a spring. So now the summation means all possible bonds. Second, the angle. So these are the building blocks of calculation of total energy of the system. So in this way, this is bond rotation, dihedral angle change. This is something called improper dihedral, means when the four atoms are present in a plane and one atom goes out of the plane due to motion, it will have a strain. So you have to account for that strain also, and that strain is computed by this term. So these four will constitute all the interactions through bond, and the interactions which are there other than these bonded interactions are called non-bonded. So we compartmentalize those interactions into two parts. One is van der Waals interaction, another is straight Coulombic interaction, electrostatic interaction. So if we can compute all these terms for the entire system, we can get the total energy of the system V. So why, another question would be that there are several methods of computing the total energy of the system, because we are not considering electrons, protons, etc. But those are there. We are using a very simple empirical relations of energy in this expression. Why? The answer is yes, there are many different possible ways of computing these energies. There are more accurate methods, but we really cannot use them here, because if we go for macromolecule, it is hard to get results using those very accurate methods. And also, for this kind of changes, when the conformations are changing as a function of time all the time, if you compute these conformation and energies for every time it is changing their conformation, then you need a method that would be simple and computationally fast. That's why there is a trade-off between accuracy and speed of computation. This is what the student should realize, that there are accurate methods, but here we are using an empirical relations. We are just mimicking the real situation with something analogous. I just give one example. For example, here, the energy profile of the bond dissociation or bond formation is like this, as a function of internuclear distance. That this profile shows how the energy will change when two atoms are coming close to each other and forming a stable bond, and then when they are coming very close to each other, then there will be repulsion. But in this kind of calculations in molecular models, we are not dealing with bond dissociation or bond formation. We are only concerned about a small region where the bonds are just vibrating comfortably. So if I can have an energy expression that will just reproduce this range, that is enough for our purpose. And that's why we make the bond using the Hooke's law that explains the vibration of spring. Now you see there are two constant terms here, Kb and R equilibrium. These two are specific for the types of atoms which are bonded. Now, parameterizing these two values, Kb and R equilibrium, we can distinguish in model. We can distinguish between CC bond, CC single bond, CC double bond, CN bond, CH bond. So all these types of bonds we can distinguish by just suitably parameterizing these two values. So in this way, all other parameters in this system, in this force field expression, we can set so that it gives a reasonable energy of this. It gives an energy of the system with reasonable accuracy. So in one side we have force field, and on the other side we combine it with Newton's law of motion, and we use a computer to combine these two, and at the end this is what we get. So simple model, simple simple methods using classical mechanics and numerical integration in computer that leads to this kind of dynamics that gives you these results. And as I have said, this is nothing but a visual translation of the coordinates that we get from the calculations. And another example of a macromolecule, not only water, we can also apply on macromolecule. This is one example of protein that is unfolding, and how it happens you can simulate in computer. So now we have entered in the domain of molecular dynamics simulations. So we have covered several subsection of your syllabus. First, the modeling, introduction to the modeling, then force field, and then molecular dynamics. There are some more. I'll cover one after another. So one simple example of application of force field, the conformational energies of N-butane, that will give the idea of energy landscape in one dimension. This is a very familiar picture for all the chemists. Now you can really compute this using just by changing the coordinates by rotating the dihedral angle of the CC around the CC bond. And using the force field expression, one can draw this profile, one can compute this profile. And now the question is, suppose and what is the basic principle of this now the question would be that even if I start from any arbitrary conformation, say the eclipse conformation, if I start from any eclipse conformation, if I just optimize the energy of the system, that is called energy minimization method, if we apply energy minimization, would it lead to the anti-conformation? This is the question. So let's have a look at the basic principle of energy minimization. This is very important for the students to realize that we start from one conformation, that is at point 1. The energy minimization will try to find out another conformation at point 2, which has a lower energy, and then at 3 at even further lower energy, and then it will reach 4, and then it will end. So how realistic is this one? So in very general sense, that if we start from a coordinate set x old and we give a translation on this coordinate set by delta x amount, it gives us a new coordinate. So x old is 1, x new is 2. So we compute the energy difference between these two, and if this difference is greater than 0 or a certain threshold, we redo it. Means we repeat the calculation so that it will try to find out another set of coordinate which has a better energy. So the challenge is to find out the delta x. So here there are different types of energy minimization method that will try to find this delta x in a different way, and that's why you have different names: SD, ABNR, conjugate gradient, etc. So one can try to learn all these details if they have interest, but the basic philosophy of energy minimization is this: it is trying to find out a better conformation, and it will end until this delta E is below a certain threshold. So this will end when the minima is achieved. So you see here, the movement of the coordinate is always downwards. So it is never upwards. So this is why if I start from this conformation, if I run energy minimization, it will go and finish here. It will never go to the anti-conformation. Means it will never go uphill and it will never reach D, the conformation, the anti-conformation. Whereas if I am lucky, if I start from this point and then I run energy minimization, I can go to the energy minimum. So this is a lesson for the students that the energy landscape is complex, it is multi-dimensional. If you run energy minimization starting from any arbitrary conformation, it will only minimize a little. It will take you to the nearest local energy minima. It will never take you to the global energy minimum unless you are really lucky. So this limitation of energy minimization method must be learned by the students. So next, realistic scenario. So we have discussed about conformations, conformational changes, force field, energy calculation, etc. And we have a concern for the most stable conformation of a system, because possibly the most stable conformation has a relation with the function of that molecule. Now, let's take an example. So one solution, suppose, let's talk about biomolecule. Suppose I have a peptide and I have dissolved the peptide in this, in water, and here this is the peptide solution. Now using an imaginary camera, if I take a snapshot of a small portion of this solution, just imagine that what we would see, we would find that all possible conformations of the system of the peptide is present in the system, but they have different populations. So the most stable one, suppose the helical one or the fully helix one is the predominant, means it has the highest probability of occurrence. So this is the probability distribution that the solution is following, and whatever measurement that we do, suppose one is trying to measure the helicity of the peptide using CD experiment. So the data that they are getting, or any NMR experiment, or whatever experiment they are performing, even ITC, thermodynamics, whatever, all the data are the reflection of the average property of all these molecules present at the same time, and they are at dynamic equilibrium. Now the question is, in computer we are dealing with one molecule, we are modeling one molecule. Molecular modeling is dealing with one or fewer molecule in computer, and in solution there are millions of molecules, there are all possible conformations. Then how could you really relate these two? Because it is not meaningful, because in computer you are dealing with the most stable conformation and not the all possible conformation with different population. Answer is no. This is where the role of molecular dynamics or different types of sampling methods like Monte Carlo, whatever, would come. It will generate all possible conformations as a function of time, and you will get an ensemble of conformation. So suppose I start from one conformation, now I have 10,000 or 100,000 conformation, and in principle it is supposed to reproduce the same probability distribution. At least in principle it is supposed to reproduce this pattern of distribution, and then only you can relate the experimental data and the prediction that you get from the molecular modeling. So this is how one has to link using statistical mechanics the molecular modeling and the experiments. And the same for the same reason, for making any prediction also, one has to consider an ensemble of conformation so that prediction becomes more meaningful. So, for example, I'm predicting, I've modeled a conformation of a small peptide and trying to say, okay, this is the best possible orientation of the side chain, or the best possible secondary structure. I would be wrong unless and until I take the average over all these possible conformation that is sampling here. Drug design. So when we talk about drug design, drug means a molecule, small molecule, slightly bigger molecule, whatever. It is going and binding a macromolecule and stopping its function, means stopping the function, inhibiting the function of the protein or nucleic acid or DNA or whatever. So here also, if we just consider a static model of the macromolecule and the drug complex, your prediction of binding affinity could be wrong, because the actual scenario could be this one. You see, drug molecule is sampling many different interactions that it can enjoy. So when you predict the binding free energy of this drug and compare between different drugs, that okay, this drug is a better binder and this drug is not. For making this kind of predictions, you must consider this kind of conformational ensemble for all protein drug complexes. Otherwise, the prediction could be less accurate. Then next question is, there is one module, structure prediction. So why structure? Because again, experiments, models, even simple models should have been fine, but why prediction of structure or knowing the structure of a macromolecule becomes so important? Let me give this example. Look at the shapes of your hand. So same molecule are in different shapes, and they are performing different jobs. So the shape matters for performing a function. So when a macromolecule has a binding pocket, means it determines the grip over another molecule. So if we don't know what is the binding, what is the shape of the macromolecule, and where is that binding pocket, and how it will have a grip over another molecule, we cannot really proceed for the drug design. For the structure prediction, let me give a brief overview that a polypeptide chain is known to the chemists. It's a polymer of alpha amino acids, and at one end this is the polypeptide chain, on the other end this is the structure, predicted structures. And why structure prediction is so important? Because of enormous number of possibilities. Suppose I assume that there are two stable conformations per residue per amino acid, and there are n number of amino acids present in a polypeptide chain. The total number of possibilities is in the order of 2 to the power n. So if a computer has to find out the best possible conformation out of this 2 to the power n, it is not going to be possible within a reasonable time, and that's why we need some method for fast prediction. So there are methods of predicting structure like homology modeling, and there are other methods also. Its philosophy could be taught in the classes, and this is for one molecule. And another level of problem is that when we know the structures of two different molecules, but we don't know how they form a complex, prediction of the complex structure is another level of complexity. So it's a problem of geometry also, that you have to find out the surface complementarity using some kind of program, and that would lead to the generation of all possible such conformation, and this is called docking. And then useless conformations would be eliminated by some means like strong and weak binding, and here also you have to distinguish it with the help of force field and several other factors. So the more accurate is this elimination, more accurate is the prediction. So this is when we don't know, or when we know that where the two molecules are binding with each other. So drug designing is another level of problem, that when we know the binding pocket, but we don't know which one is the best binder. Suppose this is one macromolecule on the left side, and on the right side there are several small molecules. They have different shapes. Shapes means not only shapes. For a chemist, shape would also mean the functional groups that these small molecules have. So a software that is, you can call it docking software, you can call it virtual screening software, whatever. It will bring each ligand one by one and will dock to this binding pocket, and then we'll find out which one is the best binder. So here also elimination is done with the help of force field and also several other factors that would accelerate the entire process of selection and elimination. A real example, it's a protein. The green color surface is a surface of a protein. Its name is MDM2. It is relevant for cancer because it binds a peptide. It's not peptide, it binds a protein. I am showing a fragment of the protein. This is called P53. It is responsible for preventing cancer. So when these two are binding, and we know this objective is to inhibit this green surface so that the red colored molecule becomes free for its function. So this is a problem of drug design. Here we need to mimic. So here the job of a chemist is to find out suitable structure of a small molecule with appropriately oriented functional group that will mimic this interaction. This is one example. You see, this is rightly mimicking these interactions, and not only it has to mimic, but the binding affinity of these small molecules must be more favorable than these peptides so that it is defeated in this competition. Now we have an idea that, okay, this is a possible molecule that can inhibit this protein. So this is the basic idea. This is the beginning of a drug design. So once you have this idea, now you go on changing the functional group, go on changing, make it bulkier, make it thinner, smaller, make it polar. So all these things one can do, and for each case one can take the help of molecular modeling and force field to eliminate the possibilities which are weaker binding. And of course, at the end, one has to go for wet lab testing. And the real scenario that once you finish the modeling in the static mode level, you have to consider the realistic scenario. The drug molecule is not a static one when it is binding to a protein. So it is continuously changing its conformation, and also it is associating several other molecules. For example, here it is associating two water molecules. So here water molecules are no more bulk water, they are pseudo ligands here. So all these are parts of the art of molecular modeling, that if you have to really predict with higher accuracy the binding affinity of these ligands, you have to consider all these details, not only the time evolution of the conformations, but also these possibilities that other smaller molecules like water, ions can enter in the system and can influence the binding affinity. And as I said, things are continuously changing. Even if you design a molecule using a computer, in reality their fluctuation, their change of orientation, their optimized conformation in the real system can lead to a different scenario that can have a different results than that you predicted. So it could be better, it could be worse also. So this is why molecular modeling is a probability. If you start with several molecules, and if you shortlist with say 10-20 molecules as a possible drug candidates, you will end up with 3 or 4 or even lesser which are really working in test tube and in the cell line. Nevertheless, it will help you to shorten the entire time required for developing a molecule of interest. Some more examples that computer simulations can do. For example, how two proteins come and how two proteins can approach to each other, which residues or which types of functional groups are important, and also how the solvent molecules are floating around a macromolecule, and how you can go into the details how the hydrogen bonds are changing with time, and how this is influencing the overall stability of the system. So this is just an overview. Now this one can go into the details and can take this data for further analysis, can go into the details through programming, using various software, through visualization, etc. So this is a very brief overview. If I just summarize that, models of molecules play important role in developing understanding. Is very important. And also for application, sometimes such models are available from experimental data. Many experimental data like X-ray, NMR would give you some models that as a starting point. Those are deposited in several portals, websites, databases. And often you need to predict models when the structures are not available. And drug design is also part of such. This quantitative estimation of stabilities of model conformations are essential, because otherwise without quantitative estimation you cannot proceed. And for this quantitative estimation, the starting point is empirical force field. It helps you to give a quick estimate. It helps you quickly compute the energy of molecular system with reasonable accuracy. It forms the basis of all quantitative calculations and modeling. The static models have limitations, and as I explained, that's why you have to go beyond static model and you have to generate an ensemble of conformations, and then only the relation between experimental data prediction and the molecular model becomes meaningful. And that's why you have to use several sampling methods, molecular dynamics, Monte Carlo methods. You can simulate and generate such ensemble of conformations under certain conditions as a chemist, like under constant temperature, pressure, volume, etc., etc. And we need to know, we need a training on the statistical thermodynamics, at least the preliminary level of statistical thermodynamics, to understand, okay, we have to relate these two through statistical mechanics. And there are certainly advanced methods for computing free energies of some processes, like binding of two molecules, and many other processes. There are several other approximations for going for higher levels of calculations that one can do if they are interested. And with this, books and journals, I'll give you these details. For study material, I believe that the study material for the students may be prepared, because if you give them the book of Leach, it is just like ocean. They don't have really that much of time, and also they would need a continuous guidance to understand what is written in these books. I have given one reference of a journal and review article. This is very good. There are several websites for hands-on learning on modeling and software. Some of them are free. One can try the trial version, free version, whatever. And there, if there is any help needed, I can always help with this. I thank you.
So
software, some of them are free. One can try the trial version, free version, whatever. And there, if there is any help needed, I can always help with this. I thank you.
hello.
Yes.
No, some recorded voices are coming from behind. Can you hear that?
Yeah.
I think the proceeding just recorded and that is being played now. Yeah, now it's okay, I think. Okay, coordinator, if you please, what to do next? May I go ahead? As a,
Yes, sir.
so, Subro, thank you very much. Particularly the way you have presented, I must mention that it is to the point. Can you hear me, Kya?
Yes.
Yeah. You are very to the point, focusing on different parts of syllabus, starting from the basics, explaining the necessity and its different components and the different requirements that we need really in the class, and outcome, including the last portion, that drug design part and prediction of structure part. I would like to start with your words. You told at the very beginning not to worry to have such a new course in our curriculum. So we are really not worried, because we have seen just now that it's a good initiation. We can probably go ahead, though it's a completely new something for most of the teachers. But still we can be hopeful to be going ahead with help, of course, help from people like you, who have already given a lot of help. There are a few questions. Some of the questions are very specialized actually. They know probably a lot. So I am screening those questions, because this is a platform meant for beginners, right? How to introduce the course and how we can go ahead smoothly in our classes. So not very few questions actually, only one question came. So let me put my own questions as a coordinator. And as I feel that we are responsible for carrying it out smoothly in coming days for DSE A1. So some of the questions are based on your presentation, academics, and mostly the questions are some technical, which are really you can avoid right now, but that is on focusing on your future collaboration with you, right? So mostly they are on that. So first question, academic. So as far as we understood that what are the things that we have to be ready with to start with, we need a little bit of knowledge of classical science, right?
Yes.
Newtons and force field. That's so classical. Number two, a little bit of computation and statistical data analysis to some extent, sampling, etc., and as well as statistical thermodynamics, right? And nowhere I can see explicit and exhaustive use of quantum chemistry, as I've understood. Okay, so fine, that's a clear understanding. Second point of understanding that computation, it is not really programming expertise as such. Rather, it has to be dealing with some standard package with a little bit of idea of optimization, minimization, etc. Am I right? Am I right? Yeah. So that is as far as understanding goes. And now the questions categorically. At one point you mentioned that numerical integration, but throughout the discussion I couldn't get where really it is needed. Integration.
Yeah, actually, I should not have used this word during this talk because it comes when you discuss the details. Integration means when we compute the total energy of a system at one conformation, and then we predict, following the Newton's second law, that if these are the forces acting on the atoms, where these atoms will go after a time delta t. Okay, so this is one step. This is one step of changing the coordinates. Now, if we repeat this again and again and again, so delta t, delta t, delta t, delta t. So over time, it will give you the changes, say over a picosecond, nanosecond, microsecond. So this is the philosophy of numerical integration.
Yeah. Okay. So at some point we need summation kind of thing. So that's why we need integration. Fine. Thank you. The next question.
Integration is not integration of calculus. I mean, not in that sense. Integration means joining.
Summation.
Summation. Yes.
Right. The second is that minimization you have mentioned. And that requires, as we have demonstrated, that some derivative-based method. You mentioned conjugate gradient kind of, for example. But does it require only the first derivative or both the first and second derivatives?
It depends on it's a ratio, possibly so far I remember, it's possibly the ratio of first and second derivative.
Both are needed. Both are needed. Okay.
Yes.
Both are.
It depends on the method, choice of your method.
Right. Which method?
In the Newton-Watson method, we need second derivative.
Well,
The Newton-Raphson method.
yeah, but here the point goes that in syllabus, something like non-derivative methods are mentioned. But in your lecture, I don't think that you have touched any non-derivative method.
See, non-derivative method, you can just tell them, as I said in my slide, I did not show any derivative. What I show that x new equal to x old plus a correction. So correction could be anything. So you can randomly also add the correction, and if that random correction leads to a lower energy, then we select it. The question of derivative comes when you want to be sure that this is a change of the direction.
Right. So at another point in our syllabus, mention is there that first and second order minimization. What really means first and second order minimization? Exactly mentioned in syllabus. First order and second order minimization methods. How do they classify? I don't know. First order
they mean the first order or second order derivative? I have to see.
We can come back later on. Okay. We can come back to it. And the next one is computation. As you have mentioned that it is not programming expertise, but running a black box kind of thing. We'll have to practice it. Then one more point that non-derivative method sometimes requires some stochastic method, rather Monte Carlo simulation. I think it is closely connected to stochastic random based method based minimization.
Yes.
So should we get at least the theoretical idea consideration in our curriculum syllabus classes, or we can avoid it?
You can just introduce two things, that there are two types of dynamics for this kind of sampling. One is deterministic, another is stochastic. Deterministic means based on Newton's law, so you know exactly where the particle will go. If you initiate at t0, where it will go at time t. So this is deterministic. And whereas stochastic, you really don't know because it is random. So these two different philosophies you can introduce, but without going into the mathematical details, because I don't know, there won't be much time for these mathematical details.
Well, in the meantime, I've got a few questions now in the chat box. So I'm just reading it out. First question goes like, how do we go about teaching this subject to the students in a very fundamental way? I think that is exactly what I tried to do today, isn't it?
Exactly. I think so. Yeah. If you need, I can share my slides partly.
Yeah, that is another question actually. They wanted your slides. I think I will manage that. Then another question, please name a free software which is good enough to learn the basics of computation. Horishadan Ghosh. So already I mentioned a software, no? One or
two. Which one? Name free software good enough to basic of basic of computation means what? Basic of molecular modeling or basic of programming? I assume that basic of molecular modeling. Actually, there is no such single software. The software has a very specific objective. I mean, if though they are free software, like if someone wants to visualize the structures and get an idea about the hydrogen bonds in DNA, protein, etc., van der Waals interaction, then the free software like PyMol has a free version, and PyMol is a paid software, but partly it has a trial version also. It has a free version, freely available, older version. One can use it. But for molecular dynamics, I don't think one really has to go and practice it at this level, because only the philosophy of molecular dynamics should be enough. But if anyone wants to have some hands-on idea, then what I do in workshop, that I tell them the philosophy, and then I give them some data which is already simulated and ask them to visualize the conformational changes as a function of time using those software. So that is free. So that software name I can write here, that VMD is a software that is free. So what I can do, that if you really want to show the students that, see, this is how the molecules are changing conformation all the time, I can give you a data file. That I can give you. I mean, I can share a data file and you load the data file in VMD software in your college or university and show them that, see how things are changing. So that would be interesting for students.
So we are expecting this kind of cooperation from you in future. One question from Pulokesh, actually not really a question, is asking, requesting to please go back to the last slide. But I think since you are giving the slides to the organizers, so it's not a problem anymore.
It is already recorded, right? So
yeah, it's already recorded also. That is another thing. And one more thing, criticality is there. One more thing, that we have got enough Ichara gesture, that the question someone asked, would probably ask that question, that okay, we are expecting from the speaker that which portion, at least to start with in the first few years, we can unofficially even we can avoid keeping it in the exam, etc., or in the classes, so that you have been given enough ishara that molecular dynamics and simulation part, and the next one, that is drug design and this complicated portion, we can really keep aside for the timing. Only the philosophy of that can be studied or discussed, and we can take the part 1 to 3, that means introduction, force fields, and energy minimization and computation solution. These 3 components out of 5 are really important for the timing to start with, unless we get really expert on these fields, right? So,
right. But I would add one point.
That
even if you this I'm telling unofficially, even if you don't like to introduce molecular dynamics in detail at this moment, but at least the student should have this idea that, okay, I am doing energy minimization is fine, but energy minimization has major limitation. And for that, you really need to have an ensemble of conformation. So only this philosophy they should learn. Otherwise, so just brief outline that one conformation is not important. Many conformation, the population distribution is important. So as a chemist, they should have this idea.
From Nupurdi, there is a question. It would be helpful if there is a stepwise discussion on teaching modalities of the entire course. Yeah, that's a very important question. Softwares needed and basic books on monographs needed topic wise. Will you get the PPTs, Piyoto sir? Yeah. Pulokesh, you will get the PPT. It is recorded actually. You will get the PPT.
PPTs are recorded.
And Tubro, so you focus on the Nupurdi's question. Next time we are expecting from you that if you can split the whole thing stepwise modalities. I mean, how we can introduce the whole thing in class. Next time we can do that, right? I think you can help.
Sure. Actually, in webinar it is difficult, but because
of course, 30 minutes is not.
If we get chance to talk face to face, it would be much easier to communicate this. And also, I can tell you one thing, that I have experienced that a study material prepared by the instructor is very helpful. And I have some basic layout on such modules. So if you want to use it, but have to decide that if you want to really prepare one study material for the university or for all the colleges, then we can discuss that if that write-up could be used for preparing a study.
One last question, sir. You have finished in time, so I would like to finish also in time. Last question, that you have covered focusing much of your attention on the theoretical part, but probably you have skipped aspects as per the syllabus. So next time, I'm not charging. Next time we'll be hopeful to get something more on topic-wise or experiment-wise discussion from you. But today is enough time we have not got. So thank you very much Thank you again on behalf of all. Thank you very much.
Thank you.
So thank you, Dankeshun, Dhonnobad, Dr. Ghosh Dotsida, for enriching us with your lecture on the DSC A1, Molecular Modeling and Drug Design. I think this first technical session was really wonderful, with your lecture followed by question answer session. Students are with us. I think they must find it interesting for your rich presentation and can go far with it in the near future with keen interest. We are grateful to you. We have got you as speaker. I think in future we need your help. Thank you, Dr. Dosidar. Meet you soon because we have to meet our many queries in future. Please be with us. Thank you so much. Thank you again. Our second speaker is Dr. Ankul Shannan. He is Associate Professor of St. Paul Cathedral College. And his topic is DSC A2, Application of Computers in Chemistry. I'm just briefing it for simplicity or simplification, that it has 60 lectures, 20 lectures on Fortran, 25 lectures on Microsoft Excel, and 15 lectures on statistical analysis, and practical. We have 12 experiments, of which at least 10 experiments to be performed. Dr. Shannan, I think he will give us the easiest approach to go with it, and we should meet our expectation in your lecture. Thank you, Dr. Shannan. Dr. Shannan, please.
Respected Principal of Maulana Azad College, Vice Principal of Asutosh College, and respected Chairman Board of Studies of Chemistry, Professor Choitali Mukhopadhyay, respected teachers and all my friends.
Dr. Shannan, you are not audible. Hello, Dr. Shannan.
Yeah.
Okay, it's okay.
Again, silence.
Problem of screen sharing.
Oh.
What's the problem? It's not sharing.
Not sharing. One thing you can do, just delink and then join again.
You just rejoin and start afresh.
Please, all others, put your camera off. Other than Kia and Ankon, maybe. Even Ankon is better. Put your camera off. Sujata Roy, if you please put your camera off. Yeah, thank you. Ankon, now we can see you. I mean, your
Presentation.
no, not presentation is not visible. Your picture is visible.
Is it now visible?
No, no.
অঙ্কন এন্টার স্ক্রিন শেয়ার কর, এন্টার স্ক্রিন শেয়ার
আমি
কর।
এন্টার স্ক্রিনই শেয়ার করছি, এন্টার স্ক্রিনই শেয়ার করছি।
না না না, অ্যালাউ হ্যাঁ, অ্যালাউ না করলে তো হবে না। পাওয়ার পয়েন্টটা
পাওয়ার পয়েন্ট খোলা আছে, অ্যালাউ করেছি, শেয়ারটা অ্যালাউ করেছি।
আবার নতুন করে কর তাহলে।
পাওয়ার পয়েন্টে ক্লিক করে শেয়ার,
আর শেয়ার করে দেন ক্লিক দ্য পাওয়ার পয়েন্টে ক্লিক করুন তাহলে হবে। প্রেজেন্ট নাওটা ক্লিক করা আছে তো? প্রেজেন্ট নাও,
হ্যাঁ সব ক্লিক করা আছে।
তারপরে এন্টায়ার স্ক্রিন, দেন ক্লিক অন
সব
দ্য
করেছি, এন্টায়ার স্ক্রিনও ক্লিক
তারপরে
করছি।
শেয়ার তারপরে স্লাইড
হচ্ছে না, শেয়ারটাই তো হচ্ছে না, শেয়ারটাই।
আচ্ছা, এন্টায়ার স্ক্রিনের পরে ওই ক্লিক অন দ্য স্ক্রিন, ওই অন দ্য স্ক্রিন যেটা আসছে ওইটাতে ক্লিক করেছেন?
তারপর একটা ব্লু শেয়ার আসবে, তারপর ব্লু শেয়ার,
হ্যাঁ ব্লু শেয়ার আসবে, তারপর ওইটাই ক্লিক করতে হবে।
এটা পাবলিক আছে তো? তোর প্রেজেন্টেশনটা পাবলিক আছে তো?
হ্যাঁ পাবলিক আছে, পাবলিক আছে। শেয়ার ইওর এন্টায়ার স্ক্রিন, কিন্তু শেয়ার হচ্ছে না।
শেয়ার এ উইন্ডো করেও করুন, শেয়ার এ উইন্ডো করেও করতে পারেন।
দাঁড়াও,
সেকেন্ড পয়েন্টটা হচ্ছে উইন্ডো।
সেকেন্ড, হ্যাঁ শেয়ার এ উইন্ডো করে করুন, ওটাই হয়ে যাবে।
প্রথমে পাওয়ার
ওখান থেকে
পয়েন্টে
পাওয়ার সিলেক্ট করতে হবে।
পাওয়ার পয়েন্টে ছোট দেখাবে, মিনিমাইজ ছোট্ট একটা দেখাবে, ওটার উপর ক্লিক করে তারপরে শেয়ার।
একটা হচ্ছে পাওয়ার পয়েন্ট প্রেজেন্ট কোথায়?
কি
পাওয়ার পয়েন্টটা কোথায়? শেয়ার
না, প্লাস করে পাওয়ার পয়েন্টটা অ্যাড করা আছে তো?
হ্যাঁ এটা হচ্ছে না।
তাহলে তুই পাওয়ার পয়েন্টটা কাউকে হোয়াটসঅ্যাপ করে দে, সে পড়ুক আর তুই বল। শেয়ার সে একটা করে স্লাইড দেখা, আর তুই বল।
দাদা একটু দাঁড়া,
কার্সারটাকে ডেস্কটপের নিচ থেকে একটু উপর নিচ করুন, দেখবেন একটা স্লাইডের মতো উপরে উঠবে, যেখানে লেখা থাকবে শেয়ার স্ক্রিন।
এই তো এসে গেছে।
এইবার তো হ্যাঁ
দেখা যাচ্ছে
এবার
অঙ্কন এসেছে।
হ্যাঁ এবার এসছে।
হ্যাঁ
এবার
ভিজিবল।
এন্টায়ার স্ক্রিন, হ্যাঁ ঠিক আছে, এটাও হবে। হ্যাঁ ঠিক আছে, গুড।
হ্যাঁ এটাই হবে। হ্যাঁ না তো স্লাইড শো তো চলে যায়, স্লাইড শো দিয়ে ইনিশিয়াল থেকে কর।
আবার চলে গেল।
ইটস ওকে।
না, আবার চলে গেল, এসেছিল আবার চলে গেল।
সেম প্রবলেম।
না, লাস্ট টাইমে যেটা করেছিলেন সেটা রিডু করুন, ওটাতে এসেছিল হোয়াট এভার ইউ ডিড ছিল, ঠিক ছিল, তারপরে চলে গেল।
নেটওয়ার্কের সমস্যা হচ্ছে কি?
না এটা নেটওয়ার্ক
একটু গলা শোনা যাচ্ছে।
না নেটওয়ার্কের
না,
না, একটু কিছু প্রসিডিউরাল ইয়ে হয়ে যাচ্ছে।
তো টেকনিক্যাল ডিফেক্ট হচ্ছে কিছু একটা।
একজন লিখছে লিভ এন্ড রিজয়েন, তো সেটা আমরা আগে এই যে
আবার হবে।
শুরু হয়েছে। হ্যাঁ ওকে।
ওকে
এটা স্লাইড শো করে দিতে
হুম
না ওকে ঠিক আছে, এটা ইয়ে করলেও হবে। হ্যাঁ ওকে,
এটা তো আমরা দেখতে পাচ্ছি ভাই, একদম ঠিক আছে, perfect.
ঠিক আছে স্যার।
It's okay now.
হ্যাঁ ওকে, ভেরি মাচ।
ঠিক আছে এখন, ইটস ওকে, ঠিক আছে।
My topic is basically applications of computers in chemistry. This is basically very interesting topic, particularly to students. Obviously, it is not so much interesting as the previous topic, because the previous topic, molecular modeling and drug design, although that was a very new topic to us, but that topic was very interesting, and Dr. Ghosdostidar also presented very nicely. Now, this topic, applications of computers in chemistry, basically there are two parts in our syllabus. First part is the introduction to spreadsheet software and statistical analysis. Now, and second part was the basics of photon. Am I audible? Am I audible?
Yes.
Now, first part is the introduction to spreadsheet software and statistical analysis. Spreadsheet software means basically Microsoft Excel. And the application of Microsoft Excel to chemistry is obviously very interesting, but our problem is to convert the experimental or spreadsheet calculation into a theoretical topic. Because our syllabus, there are two different parts in our syllabus. One is the theoretical part that consists of 50 marks, and second one is the practical part that consists of 30 marks. Out of this 50 marks theoretical paper, 2/3 goes to Microsoft Excel application and 1/3 to basics of photon. Now, Microsoft Excel application in chemistry, this is obviously a new topic to us, particularly to our students. Although our students are already familiar of plotting Excel graphs in their semester 1 to semester 3 courses, even they are more smarter than us. But in this paper, our main aim is to convert, because both Microsoft Excel and basics of our photon language, we know that these two are basically computer application, and our view is that we will sit in front of a desktop or a laptop and we'll do some calculations. But our first objective is to convert those desktop applications to theoretical part. This is our main problem in this case, because there are very few books are available which describes the theoretical part of Microsoft Excel. For photon, there are lots of books are available, even in internet, that describes the theoretical part of the basics of photon. But in case of Microsoft Excel, very few books are available. Most of the books are concerned with just calculation of Microsoft Excel. Actually, the power of Microsoft Excel, we don't know actually what is the basic power of Microsoft Excel. We know Microsoft Excel as simply a spreadsheet calculator, but it is not like that. It is not just a spreadsheet calculator. Rather, it can calculate even very simple, for example, H plus Hartree-Fock calculation also. This is a very nice part of Microsoft Excel. And another interesting part of Microsoft Excel is the capability of its optimization problem using its solver. We just learned some optimization problem. In Excel, there is a one function that is called Microsoft Excel solver, and that optimization of that solver is really fantastic. Actually, there is a practical in our syllabus, that is the solution of time-independent Schrodinger equation using Numerov method, say for particle in a box or one-dimensional harmonic oscillator. We can apply the solver optimization there, and using that solver optimization, we can get almost accurate result or energies of energy levels. So this is actually the power of Microsoft Excel. Even using Microsoft Excel, that is also included in our syllabus, something like numerical integration. That is, we can even apply Simpson's rule, trapezoidal rule, that's all are present in our syllabus. Or we can even numerically, we even perform numerical differentiation, that is also present in our syllabus. So these are the actual basic power of Excel that we have to investigate. And I told that our real problem is to convert the programs of Excel into theoretical concept. Now, for Excel, our syllabus we can broadly classify our syllabus into three major parts. First is the elementary Excel operation or elementary spreadsheet operation. We will not concentrate too much in the class this year for elementary spreadsheet operation, because students are already familiar with this elementary spreadsheet operations. They know how to create a spreadsheet, or how to enter data or format, or how to incorporate tables in Excel, how to calculate, or how to draw graphs in XY plot. They know everything. So this elementary spreadsheet operations part, we can easily bypass during our lecture in class. But this should be present in the syllabus, and questions may be asked in the examination. And there is a mistake here, least square analysis. This should be LEAST, the least square analysis and numerical modeling. And third one will be statistical analysis using Excel. These two parts are very important. The least square analysis, numerical modeling, and statistical analysis using Excel. Now, what is part one? Part one of the syllabus, what I mentioned, that it consists of creating a spreadsheet, entering and formatting information, basic functions, formulas, creating charts, tables, graphs, incorporating tables, graphs into word processing documents, and simple calculations. These parts are very easy, and students are, I said the students are already familiar with this part. Part two is the linear and nonlinear regression analysis part. We know that Excel can perform linear and nonlinear regression very easily using different Excel inbuilt function. But in this theoretical course, we have to use we will use the inbuilt function, but we will teach students how to calculate, or how to initiate the problem using step-by-step Excel calculation. So first part is the linearest and least square, then numerical curve fitting, regression analysis, and obviously Excel solver goal-stick function, numerical modeling. And there are two parts in numerical modeling. One is simulation of pH metric titration curve, and another is the numerical differentiation and integration part. So these are our second part, and this part one and part two together, there are 25 lectures are there for part one and part two. I think that 25 lectures will be more than sufficient, because part one, we don't need anything to explain to students, but for part two, we need something to explain for students. Linearist, the Excel solver, goal-stick, how solver works, what is the method, or what is the internal mechanism of working of solver function, how goal-stick function occurs, and obviously, finally, numerical modeling of pH metric titration, numerical differentiation, and numerical integration. And third part of our syllabus is the statistical analysis in which first part is the descriptive statistics using Excel. This part is simply the calculation of average, standard deviation, variance, etc. using Microsoft Excel. This can be easily done. Second part is the normal distribution, or what is called Gaussian distribution, how to calculate the area under a Gaussian curve. Then syllabus consists of errors in measurement and their effects on the data set, how errors can be measured using Excel and what is the effect of data set. And then the most interesting and most difficult portion of this to our student is the hypothesis testing part. This is completely statistical part, and obviously this is something different, this will be very difficult to our student, but using Microsoft Excel we can classify it into a very easy part. And then the t-test and f-test. Now before going into details, I will first discuss some of the recommended textbook. Although there are several textbooks, actually 6 textbooks are referred in our syllabus as reference book, but I will like to mention slightly different books which will be very helpful to students as well as our teachers. First one is the Data Analysis for Chemistry, an introductory guide for students and laboratory scientists by Hibbert and Gooding. This is Oxford University Press book, but this is something old book, 2006 edition book, but it is not available in our College Street market, but it is now available in Amazon. Price is not too much high, around rupees 500 to 600. Students can purchase this book. This is a very good book, not very large book, a short description of Excel, but this is from the light of analytical chemistry. These authors obviously are from analytical chemistry portion, lights of analytical chemistry, but this book covers almost 60 to 70% of our syllabus in Microsoft Excel, not more than that. Second book, to me, this will be the best book, and this is almost according to our syllabus book, that is Data Analysis for Physical Scientists, featuring Excel by Les Kirkhope. Cambridge publication book, second edition is available, but this is a very nice book. Les Kirkhope was a physicist, but the only problem is that the price of this book is very high. It is almost 5,000 to 6,000 rupees, but we can get a very cheap Amazon Kindle version of this book that also cost around 1,500 to 1,600 rupees. But this book is actually, this should be the textbook in our syllabus. It covers almost 80 to 90% of our syllabus, and it is also not a very big book. It is a small book. And second, what is important is that there are lots of examples in this book for different types of statistical and data analysis. And most of the examples, few examples are from physics, obviously, but other examples are from real gases, thermodynamics, chemical kinetics. So this will be very easier, very interesting book and very good book. I think this should be our textbook, but unfortunately, this is very, very much costly. But my recommendation to our teachers that you may purchase this book as Amazon Kindle version, but the problem of Kindle version is that we cannot share the Kindle version to other. We can't print the Kindle version. This is the problem. If anyone can get the ebook, then it will be very fine. Then third one is the Fundamentals of Analytical Chemistry by Holler and Crouch. This is not the Microsoft Excel application book of Holler and Crouch, rather than the Analytical Chemistry book of Holler and Crouch. It explains all the details in the theoretical portion of Microsoft Excel, and it is also not very costly, around 800 rupees. Its price is around 800 rupees. And another thing is that this Fundamental of Analytical Chemistry by Holler and Crouch, this is also included in our another paper, that is Analytical Methods in Chemistry. So I think we may recommend students to purchase this book, Fundamentals of Analytical Chemistry by Holler and Crouch. Remember, this is not the book for practical examination, that is the Microsoft Excel application of analytical chemistry. This is not that book of Holler and Crouch, but this is simply the fundamentals of analytical chemistry. So out of these 3 books, my first favorite book is the second one, Les Kedcook books. Second one, this fundamentals of analytical chemistry, and third one is the data analysis by Hibbert and Gooding. Next, there is nothing to say about the part 1 part. I already said that we are
Not audible.
Ankon, you are not audible. Something is wrong somewhere. Please check. Ankon, can you hear me? Yes, left. Coordinator, please remind him that regarding time. 4:45 is the limit. Okay, if you want to extend, no problem, but otherwise, you should remind.
Actually, you can convey this message as you are the coordinator of question answer session. I think you can do this with the speaker.
Okay, I see.
Because we have the question answer session.
But Kia, please contact him. আমার মনে হয় উনি বুঝতে পারছেন তো যে উনি ডিসকানেক্টেড হয়ে গেছেন।
হ্যাঁ, রাইট। কল হিম।
কিভাবে কন্টাক্ট করব?
ওনাকে ফোন কর যে উনি যে ডিসকানেক্টেড হয়ে গেছেন, উনি কি সেটা বুঝতে পারছেন?
অঙ্কনকে দেখাই যাচ্ছে না, না? অঙ্কন ইজ
না, হি হ্যাজ লেফট।
না, ও কোনোভাবে হয় কেউ ডিসকানেক্ট করে দিয়েছে এখান থেকে, অথবা উনি নিজে কোনোভাবে হয়ে গেছে। তুই একটু ফোন কর।
আমার মনে হয় ওর ইন্টারনেট কানেকশনটা চলে গেছে।
সেটাও হতে পারে।
হ্যাঁ, ওনার ইন্টারনেটটাই ডিসকানেক্টেড হলো, আমি যেটা বুঝলাম।
হ্যাঁ, কিয়াদি একবার ফোন করে দেখো তুমি।
শোনো, আমি আমার ফোন থেকে ফোন করলে আমি নিজে ডিসকানেক্ট হয়ে বেরিয়ে যাবো। আমার ফোনটা খুব ডিস্টার্বিং। তোমাদের কাছে
let me
আমার থাকলে তাহলে তুমি প্লিজ ফোন করো। আমার ফোনটা রিয়েলি ইন প্রবলেম। আমি টাচ করছি না আমার ফোনের জন্য।
ঠিক আছে, আমি করছি।
কেউ কি রেকর্ডিংটা এখন বন্ধ রাখবে?
রেকর্ডিং কি এডিট করা যায়? মাঝখানে একটা এডিট করা যায়?
হ্যাঁ, রেকর্ডিং এডিট করা যায়। অবভিয়াসলি এই অপশনটা আমরা কেটে দেবো। এডিট করা যাবে।
আই থিংক সো। মাঝের পার্টগুলো সব এডিট করে দিতে হবে।
হ্যাঁ, আমরা ওটা এডিট করে তারপর
অঙ্কন রাইট নাও ইজ নট বিং এবল টু রেসপন্ড। তিনি এখন উত্তর দিতে পারছেন না।
So it's a big problem.
After 1.5 minute COVID message.
We have so many questions here.
Yeah.
অঙ্কনকে হোয়াটসঅ্যাপ করা যাবে কি? অঙ্কনকে একটু হোয়াটসঅ্যাপ করা যাবে?
করে তো দেখতে পারি, আর হবে কিনা জানি না।
হ্যাঁ, একটু দেখো না, একটু হোয়াটসঅ্যাপে রিং করে কিছু যদি হয়। অনেক সময় হোয়াটসঅ্যাপে রিং করলে হয়ে যায়।
আর ইন্টারনেট চলে গেছে আমার।
ঠিক আছে, চটপট শুরু করে দিন।
স্যার একটা স্লাইড শো মোডে দিন।
কোথায় আটকে গেছিলাম, কোথা থেকে?
ওই লিস্ট স্কয়ার পাতাটা খোলো।
ব্যাক কর স্লাইড গুলো। এবার রান করা।
বুকস অবধি করেছিলেন স্যার, বুকস অবধি।
হ্যাঁ, বুকস, এক্স্যাক্টলি বুকস
হয়েছিল।
হ্যাঁ, আরেকটু এগো, যেটা খুব কস্টলি সেইটা, সেই বইটা।
বই অব্দি ছিলাম।
হ্যাঁ হ্যাঁ
কেউ পড়ছিল?
হ্যাঁ, এর পরের স্লাইড থেকে শুরু কর।
Now, first part of our Excel syllabus, that is very preliminary part that represents the creating of a spreadsheet, etc. And students are already familiar with that part. So I will skip that part to the second part. Obviously, first part is not out of the syllabus part. Questions may be asked from that part, but I don't think that it is necessary to teach that part in our class. Now the second part, that is the least square analysis part. In this least square analysis part, the first thing which is present in the syllabus, which is the least square fitting to a straight line. Now obviously the least square fitting to a straight line, this is very familiar to our students, but they know how to use Excel for a least square fitting, but they don't know what is the actual procedure of least square fitting. So the actual procedure of least square fitting, we will have to use the actual procedure of least square fitting, that is the assumptions, then detailed derivation, and then step-by-step implementation of the least square procedure in Excel. Step-by-step implementation means means simply the calculation of average value, slope, intercept, standard error of regression, standard deviation of coefficients of slope, intercept, confidence intervals, and obviously uncertainty. So students must know what are the different steps for the least square analysis in Excel. They know simply that they are using Excel and doing least square analysis just by clicking the mouse, but that is not the main thing. And obviously they have to calculate slope, intercept, and obviously they have to use this leanest function. Using this leanest function, they can perform the least square analysis. Actually, this leanest function is mentioned in our syllabus. And the most important part of this leanest function is that there are 9 different outputs of a leanest function. When a leanest function is operated, 9 different outputs will be there. And obviously, we should explain these 9 different outputs to students, and they should know the different outputs and what are the meanings of different outputs. Some outputs will represent slope, intercept, some will represent standard error of regression, obviously F statistics, some will represent the degrees of freedom. What is the meaning of degrees of freedom, or what is the meaning of sum of squares due to regression and residuals. This part is very important. Otherwise, if students uses this leanest function in Excel just by clicking the mouse and doing the calculation, that will not be enough. In theoretical paper, we have to know what are the exact procedure of doing leanest calculation. Next part is the use of trend line in Excel. Students are also familiar with this trend line in Excel, but they don't know what are the different advantages and disadvantages of using this trend line option. Then use of solver. I already said that solver is a very fantastic function in Excel. We can optimize different types of problems using solver. Even we can use solver to solve Schrodinger equation, time independent Schrodinger equation for say particle in a box, one-dimensional harmonic oscillator, etc. And solver performs very nicely there. Using solver, we can easily calculate 10, 20, or 30 levels of energies for particle in a box, or simple harmonic oscillator, or some other problems for radial part of solution of hydrogen atoms. etc., or Morse equation, Lennard-Jones potential. We can use solver to optimize there and to calculate the energy. And what students don't know that solver uses a generalized reduced gradient nonlinear optimization method. We just learned different types of nonlinear optimization method, first order nonlinear optimization method, first order method, second order method. Actually, the steepest descent method and this method, this generalized reduced gradient nonlinear optimization method, this is actually the first order.
May I interrupt you? Actually, it's a very common platform, organic, inorganic, all specializations there. So better not to. You may skip some of the details part. Rather, more importantly, we are running short of time. We have already exceeded. I mean, 45 was the time limit. Right? Thank you.
And obviously, what are the limitations of solver? And using solver, we can perform different types of nonlinear least square fitting using equations like x plus b by x plus c, like, or first order consecutive reaction to calculate the different type rate constants. Now we can use the Excel linear correlation factor, that is R. This is not the R square, but we can directly calculate R. And another thing is that is also present in our syllabus, that obviously different types of regression analysis. One of them is parabolic regression analysis using matrix inversion method. And this parabolic regression analysis, we can easily apply this to, say, our experimental phenol water experiment or so on. And during this parabolic regression, we have to use Excel's different types of Excel matrix functions, that is matrix inverse, matrix multiplication, etc. Now, after this least square analysis method, there are two different simulation techniques. One is pH matrix simulation technique, and another is numerical differentiation and integration. In this pH matrix simulation technique, students will generate plot from generalized equation, not from experimental data. They first calculate the generalized relation between volume of acid and base, that is the ratio of volume of base to volume of acid. This is obviously present nicely in Holler and Crouch book and also R.D. Levy's book. Obviously, strong acid, strong base, weak acid, weak base, diprotic acid base, they can easily perform, but not using experimental data, but using data generated from generalized equation. Then our numerical differentiation and numerical integration. Obviously, we are already familiar with trapezoidal rule, Simpson's one-third rule. So all this can be performed in Excel very easily. So this is the first part, part 2. Then third part or part 3 is the statistic analysis, and this part, 15 lectures are allotted for this part, and this part will be actually something difficult for our students, but we can't get away from this part because this is a separate part in our syllabus containing 15 lectures. We will start from hypothesis testing to go to different types of error, 1 and 2 tail distribution, then a single sample test concerning of a single mean. We have to use different Excel functions, say norm dist function, 2 sample test mean, paired t-test, variance test using different types of error, and then sampling distributions. These are all different types of statistical functions, random variables. These are all different types of statistical functions. So this t-test, f-test, all are present in our syllabus, and although there are different inbuilt function in Microsoft Excel to perform this t-test, f-test, etc., but we don't need that in our theoretical paper. We need how to calculate t-distribution both theoretically and step by step in Excel. Obviously, t-test, f-test, etc. Now, now one thing is that Excel students t-distribution in Excel, different functions are present, but the syntax of different functions have changed from Excel 2010. We have to remember that Microsoft Excel version before 2010 and Microsoft Excel version after 2010 are slightly different. We can't say we will use Microsoft Excel version before 2010. We can't use that after 2010 or vice versa. That we can't say. But there is slight difference between different syntax of different Excel functions there. Then sampling distribution. This is also a statistical part. And third part in this case is the random variables and probability distribution, because normal and Gaussian distributions are present. There are different types of Excel functions for this normal and Gaussian distribution, that is norm.dist, norm.s.dist, norm.inf, that is inverse of normal distribution they can calculate. Then we will go to goal-seek function. Now goal-seek function, I will just, you can see that it uses Newton-Raphson or secant method. Obviously, we can compare, because students will be familiar with Newton-Raphson method because that is present in our CC course, that is the core course paper. Numerical analysis is present. Photon practical using Newton-Raphson method, that will be also there. But so students will be familiar with the Newton-Raphson method or even with the secant method, and goal-seek uses this Newton-Raphson or secant method. This is one important, obviously, optimization of Excel. And practicals. There are 12 different practicals present, and according to syllabus, we have to perform student at least 10 different experiments. Actually, except the 11th experiment, that is use of spreadsheet to solve one-dimensional Schrodinger equation using numerab method, almost all other 11 experiments are more or less similar, either using Linus function or using solver or using goal-seek. So that 11 experiments will not be a problem to students. My recommendation, just perform these 6 experiments using, including that Schrodinger equation solution, and perform any 4 from the rest of 6 experiments. That will be total of 10 experiments will be there. So just my recommendation, perform this 6 experiment and another 4 experiments from the rest one. So obviously this is the Excel part. And then introduction to photon. This photon part, obviously, it consists of 1/3 of our syllabus. So it is slightly less important than Excel to our student, but it will also be very interesting part. And a knowledge of theoretical photon will be highly essential. Otherwise, students could not perform the practical exams, practical experiments of photon using photon. Now, photon syllabus, we can divide photon syllabus. First of all, overall photon is a very huge topic, and it is not so easy. So what we will concentrate only on some basic parts of photon. Only on some basic part of photons. If we go beyond that basic part, then it will be very much difficult for our students because they don't know anything about programming language. Now, basic part of photon means first part, basic elements of photon. Different parts are there, structure of photon, program, constant and variables. Then basic part includes arithmetic statements, calculations, assignment statements, integer arithmetic, exponentiation, different types of internal functions, conversion function, and obviously simple problems using mixed mode arithmetic. These simple problems you can get from basically from the book of Shom series, although that book is too much costly for students, it is already almost rupees 2000. Its price is almost rupees 2000 in Amazon, but it is a very nice book and students can use. Teachers can also use that book, the book of Showham series that is mentioned in our syllabus. That is the 10th book. The 10th book, that's Showham's outline of Photon 77. So from that book, students can practice different types of mixed mode arithmetic problem or simple different types of problem. Then we can use some complex data type, because complex data types are very much important. We can use different sample programs there, quadratic equation having complex root, normalization of quantum mechanical state vector, checking whether some functions are orthogonal to not. If we don't know complex type of data, we can't do this type of calculation. These calculations are very easy. Students will easily perform this type of calculations. Then there are some intrinsic functions of photon. These are also present in our syllabus. Apart from some general trigonometric function, these logs, square root, etc. These different types of functions. Students should be familiar with this type of function. Then they should be introduced with this initialization of variable, implicit NaN statement, different input and output statement. Then the major part of this basics of photon is the program design and branching. In this case, we will use flowchart. Obviously, flowchart is very basic things, and we can't go too much extent into this flowchart. Then our the major part of our syllabus contains the logical and relational operator. So this logical and relational operator part, this is very easy part, and we have to go in details with this logical part and relational operator part. And obviously, simple problems can be asked from this part in examination. Very simple problems and or not, different types of operator and how to use that type of operators. Then our control construct branch structure, our else and else if construct, our go-to statement, and we can use, I have given two examples, quadratic equation problem or evaluating a function of two variables, but we can use any type of simple problems here. Then we will go for loops. There are do loops, and this do loop part is very important. Students should know everything about this do loop and how to end a do loop, how to nest a do loop or nesting loops. This part is very important for program. Actually, this is the heart of the photon program logic. I am suggesting several sample programs here. That is determination of factorial of an integer, Fibonacci series, calculating GP, what an Armstrong number, binomial probabilities, calculating different Taylor series expansion function, sin x, sin inverse x, log x, etc. These are simple problems which can be asked in the examination. Then array. This is another important part of photon. Array. Array should be introduced, obviously, in a logical way. How to initialize the array, how to declare the array. And one thing that should be very important, we should note that when should we use an array? Why we should use an array? When we should use an array? We should not use array everywhere because it consumes large amount of computer memory. So when should we use array? For simple example, during the calculation of average, standard deviation, and median of several numbers, we should not use, we may use, but we should not use array for calculating average and standard deviation. But for calculating median of several numbers, we should use array. Otherwise, we can't calculate median. And there are searching and sorting problems in array. Different types of programs are there. Sample programs are there. Students can perform these sample programs. Then two-dimensional arrays. Obviously, these two-dimensional arrays are present in our syllabus. That is matrix. Two-dimensional array means matrix. Basically, what are two-dimensional arrays? What different types of problems we can perform in our syllabus. Syllabus includes matrix addition and multiplication. So, students should know what is the logic behind this matrix addition or matrix multiplication. So, I've written there in the parenthesis of matrix multiplication, that is detailed algorithms of matrix multiplication. Details algorithm of matrix multiplication. And then dot product and cross product. And verifying whether a matrix is symmetric or not, say whether a matrix is an identity matrix or not. This type of problems can be asked in the examination. And our last topic is the introduction to procedure, that is function and subroutine. This part will be slightly difficult to our students, function and subroutine. We should introduce a very basic ideas of function and subroutine to students. What is the subroutine? What is the function? And what is the syntax of calling a subroutine? And obviously, what is the difference between function and subroutine? And in the last, one type of function I should mention, that is recursive function. The function can be called recursively using factorial and Fibonacci series. We can show how functions can be called recursively, because recursive calculation of function is very important. Otherwise, you can't calculate Legendre polynomial, associated Legendre polynomial, spherical harmonics, etc. All are included in the semester 5 syllabus of our students. So we should use this use of this recursive function is very important to us. And this is all of Fortran. I don't think too much of Fortran will be necessary. And recommended books means there are two books are already recommended in our syllabus for Fortran. One is Rajaraman's book and another is Computer Programming of Rajaraman's book and another is Shom series books. The book of Rajaraman is very cheap. Students can easily purchase that book. But I already mentioned that Shom series book is too much costly. Don't recommend students to purchase the Shom series book. It is actually not always available even in Amazon because it is a very old book. If you order Amazon then send you by printing this book. This is not readily available in Amazon. So we can recommend students to purchase that Rajaraman's book. So this is all about Fortran. Thank you. আবার কি ইয়ে চলে গেছে নাকি?
না না না, you are okay. Yeah, it was okay.
বুঝতে পারছি না।
Then have you finished your talk?
Yeah.
Okay. So presentation, stop presenting then. Thank you. Yeah. So thank you. Though we were disturbed a number of times because of some technical faults. So today it was not our day. I mean, Hong Kong's day. Anyway, he has covered many things. Excel, Fortran, so many things actually there in his part. And I will just pick up the salient features that he has helped a lot. That is, first of all, he raised the problem that Excel, its theory part, because it is 2/3 of the theory course of BSc 2 is Excel, but it's really problematic to frame questions as theory questions from these portions, because really Excel is meant for practical purpose, right? So that's a question, but that will resolve later on. We have some good friends who know Fortran and Excel both very well. The second question, he has taken the labor of putting good references, and visibly he has gone through all those references and he has picked up his own choices as well. Some of them are not even mentioned in syllabus curriculum book. And I would request on this aspect that if we get a write-up from you, particularly on the use of Excel in statistical application part, and a solver, bullseek, and linest application part, so that I will or we will have to highly appreciate. And then I'd like to, so far no questions came up in the chat box, so let me handle it in my own way in just a few minutes. Let me present something, a few seconds only, that would compensate actually, complement Ankon's thing. The last session in Subro's lecture, the questions unanswered, but it was the last question. Someone from I don't remember who put that question. It was like that: how can we get study material? In spite of so many references, she or he was asking study material. So that means she or he is indicating that we want something very readily available, some study material from the experts, right? So with respect to that point, I am answering this question. Actually, Ankon is in a very good position to answer in this way as well, because he is very much involved in this process, what I am going to talk on. But somehow he has missed.
I will provide study material for Excel part.
Excel part.
Detailed study material. I will provide detailed study material for Excel part. That is part 2 and part 3 part, not the first part. That is very easy.
That's good enough. That's good enough.
So detailed study material.
Asutosh College, thank you very much for having this 4 days. And the first day DSE A1 and A2. And this is the first I'm demanding that this is the only DSE course whose complete course materials are available. Almost, I should add an almost. Nothing is complete actually in life. And in print form, it is available right now. And both theory and practical, and to the point as per syllabus. So almost all of physical chemistry teachers, they are well aware of these things, or will be aware very soon after starting their semester classes. And this is courtesy to BSc, I mean Bankim Sardar College and Physical Chemistry Teachers Forum, PCTF. They have already organized 2 workshops and had published 2 volumes, 1 and 2, in 2019 and 2020. In the first one, I remember that our present Board of Studies chairperson, Choitali Di, she was very much with us. We got her blessings and love in that endeavor.
Sorry.
Yeah. And this is the picture of the Mathematical and Computational Application in Physical Chemistry, the first volume. And this is the second volume. Sometimes we forget about the Grammar Medho, and we get focused with Madhusudan from outside. So this, I am just referring the Medhos of, right? So please excuse me because I'm using that term, Medho. And I am giving you the, okay, Fortran Basics, written by Suparna Chakraborty, volume 1, page mentioned. And then Spreadsheet MS Excel, Suchandra Bishwas, again in the same volume, page mentioned. And Statistical Analysis part in the second volume by Nabokumar Bera and S. Ghosh. Okay, this is a bit huge one, but you can pick up the right things from here selectively. And then practical classes for this course. Excel exclusively, there are 12 experiments, and I have picked up that there are exclusively mentioned 8 by Excel, right? 1, 3, 4, 5, 8, 9, 10, and 11. And then possibly are possible by both Fortran and Excel, because in theory part both Excel and Fortran are there, right? So in the experiment part, it is not clearly mentioned that whether Excel or Fortran. So it can be by both experiment number 2, 6, 7, and 12, right? But since in our core course an exclusive Fortran lab course is there based on numerical analysis, this is the paper number 5th semester, paper number 11. So I think we have done enough of Fortran. So we may assume that all 12 experiments are to be done in this DSC course by Excel. Well, in that case, Fortran plus Excel, all experiments except 11 were excellently written by Suchandra Bishwas in PCTF volume 1, page this to that, except 11 that Ankon was discussing, the most challenging and interesting one, and that is also there. in the same volume, and it was done by me myself. Volume 1, page this. So the full experiment setup is with you. So don't worry. And we are getting added that the write-up from Ankon, that is good enough. But even if you don't get it, you can, for the timing, you can run, you can go smoothly. Okay, if we get it, that will be even added beauty. Well, so that's all from the reference part that I was trying to mention that what we mean. I'm presenting, stopping my presentation. So now the question answer session is open. I think so much he has discussed in details. Yeah, there is no excellent session thanks to organizers. Yeah, not really any question is there. So the detailed questioning, it's not much time is left actually. We have extended long ago. We are running behind by 30 to 40 minutes actually. So still, if you come up with some questions, or I can put 1 or 2 questions only. Well, is there any question? I don't find anything in the chat box.
No, I can put a question.
Yeah, of course.
For me,
yeah.
My question is that regarding the Excel practicals, they are supposed to plot a few graphs which are experiment based. So have they to perform the experiments to the data of the graphs?
Lot of sounds are coming.
Hello, am I audible?
Yeah, now audible.
I was asking that in the Excel practical part, there are 10 experiments. Now, a few require some experimental data. So students have to perform the experiments and then do whatever they have to do with their own data, or data is to be supplied to them.
Data has to be supplied. We have to supply data.
They are not doing any experimental work.
No. They will not do any
experimental. Data has to be supplied. They will be doing only the Excel part. Okay, thank you.
Yeah.
And in most of the experiments, data can be generated in Excel.
Okay. No, but the nature practical data needs to be given for the nature of the curve, etc. Huh?
Obviously.
Okay. So that's our part.
Some long questions is there from Chem IQ. Applications of computers in chemistry, we can see that the syllabus contains use of Excel both in theory and practical. So whether it will be better if experts in physical chemistry get involved teaching the students? Actually, I want to know what colleges are actually doing. Yeah, of course, Ankon. I think it's obvious.
Physical chemistry teachers should involve in teaching.
Yeah, I think so.
Physical chemistry teachers should involve in teaching because they have to take practical examinations. They will be the examiners of practical examinations. Yeah. Nobody else. We can't engage teachers from other stream to take chemistry honors practicals. That's impossible.
So I'd like to add one more point, that another good announcement actually. Recently, we have concluded a long 13 lecture series by PCTF, Physical Chemistry Teachers Forum, and Ankon was very much one of the resource person in that endeavor. And we are going to publish all those lectures very soon. So again, that would help a lot. And in that series, we actually have covered the grammatical part, I mean the language itself, Fortran, and its uses, applications, and covering the syllabus as well. So that would be an archival item, I think, later on. But one more point that somehow we have to keep in mind, teachers and students alike, that the basic philosophy that Subru was talking about, this word, many often philosophy. So the basic philosophy while talking about learning Excel and Fortran, it is not our purpose to know what Excel is really, how powerful Excel is. Excel is very powerful, but we don't need to know all those power of Excel and Fortran either. Rather, we being chemistry students, we'd like to know how we can extract the essential parts of both Excel and Fortran for our purpose. After all, we are chemistry students, right? We are not going to be Excel expert or Fortran expert. And there is not any rivalry between Fortran and Excel. So we are not advocating either behalf of Fortran or Excel. Just we will take the essence of
Both are completely different.
Yeah.
Both Excel and Fortran are completely different.
Yeah, that's why there's no rivalry actually. Sometimes we present in that way that okay, it is better, it is not better. Number two, yeah, you are right. It's completely different. Fortran is clearly a language, programming language. Excel is no way a language. Right, it's a package, really a package. Onkon has mentioned rightly that we can do a lot of things using Excel, but definitely we are not going to use Excel in that lot of things. Interesting, even maybe. Because we have Fortran with us. So why should we go for programming in Excel? We will be just using as a spreadsheet. Even the most interesting experiment that Ankon was mentioning, number 11, numerical method, sorting, aggregation, solution, that also clearly mentioned in the syllabus, use as spreadsheet, right? So you will be not really doing a lot of programming in Excel. So that you have to keep in mind. So don't worry, we are not going to be expert in Excel or Fortran either. So thank you very much. I think there are no questions and we have taken a lot of time. Thank you, Kya.
Okay.
And Maulana Azad also.
Okay. Thank you, Dr. Shanal, for such detailing and we know right now we know every nook and corner of this part. And in addition, I must thank Dr. Priyotos Dotto. Actually, in addition to Dr. Shanal, he has also acted as a speaker. So I must thank both. And I think from my today's experience that this webinar is going to be very much helpful for us. They have provided us with the study material, which is excellent for us in the form of guidelines. I have one question, how to get the study material, as we are not the member of PCTF, your forum. So we need as soon as possible because students are almost in the midway of their learning. So as soon as we get it, we can convey this material because the syllabus we have to finish before Puja or within December. So please, we need it as up. I'm thankful to our speakers. Again, I have some. I should ask one thing. Maybe Dr. Shanal or Dr. Dotto can answer me. As DSC has no previous type of, I think, model of questions, what students very much like, because they practice with this model of questions and they go to exam hall and it is easier for them to answer. If you can provide us a question bank, suppose questions with proper marking, so that they can have a good idea, they can have a lot of practice, they can get a good score. Can you think of that? We really need a question bank on this part.
Yeah, thank you very much personally for raising this very important question. It's really very important having question bank. And for your information, in those PCTF 2 volumes, lot of questions are tried on by me and many other resource persons. So there are good many articles and good many questions from that book.
So when to get this one, Priyotosta?
Yeah, it is already available. For the time being, I think you can approach Suchandra Biswas. I'll share the phone number of her if you don't have. And of course, I can share my phone number if you don't have. I am also one of the persons from whom you can collect the books.
I think
Madam, I have the copies of those books.
Oh, that's fantastic. So please share with us if probable. I don't know, in this pandemic situation, can I purchase online? Is it possible?
No. I'm not that smart. You can get it personally from me.
Please think of sharing them as a soft copy or in that kind of, I don't know how to get it. So students will be very much helpful with your study material.
The second volume can be obtained from Saurabh Book House because they are the publisher actually for both the volumes. And the first volume, I'm not quite sure.
So please, in the app, can you share the publishing house so that we can order, because phone number is there, we can order. That is the point. Phone number of publishing house, if we have, we can order through over phone. This is
Okay, I can
one.
come back to this point in your group also. Okay, I'll give some information.
And another thing, Ankon, Dr. Sharna, you are telling that your webinar, you have a series of webinar in your PCTF and we'll get it, right? So please, we'll wait for your that kind of material. That will be very much helpful for us also. Thank you very, very much. We are really enriched with your lectures. Dr. Sharnal, again, thank you, Piyotosda. You both have enriched us a lot. Thank you. I think the session will be ended here. We are very helpful with all speakers today. Two speakers were there, and we'll meet tomorrow. We have polymer chemistry tomorrow, with speaker Professor Dipankar Chattopadhyay. So meeting you soon tomorrow at 3 p.m. Thank you so much. Thank you all, and thank you Choitalidi for your presence. And I think you will be tomorrow and each of 4 days. Thank you Choitalidi, and thank you everybody.
Thank you, Kat. Give a big smile at least. Yeah.